All right, we're going to continue our conversation about solving, and what we're going to do today is look at a specific type of equation called a proportion. And a proportion is when we have one ratio set equal to another ratio, or basically one fraction equal to another fraction. All right, and what I want you to do is really just think about the operations that's involved with a proportion. All right, and so this is really just focusing on linear equations with variables on both sides. All right, and what I want you to do to get you thinking about this is that we've really already done some proportion work already, even though we didn't use that terminology. So you really already know how to solve these, but we want to make sure we pull your attention to specific details to help you work through these. So go ahead and work the opener, 1A, 1B, 1C. All right, solve these three problems, flip the video back on, and we'll see how you did. All right, so hopefully this didn't take too long because these are really all just three basic math facts, right? And so once again, let's just review this bar, all right, is representative of division, all right? So this is what divided by 3 is negative 5? And the answer is just negative 15. And so we've just kind of been using the cover-up method here, right? So same thing over here. What divided by 5 is 4? So if I cover that, 20 divided by 5 is 4. And so that's why our answer is 20. Now, this is a little bit new, so this might have thrown some of you just a little bit because we haven't asked this question with the variable in the denominator. It's always been the numerator, but it's really the same question, right? So this is 15 divided by what is negative 3, right? So 15 divided by negative 5 is negative 3. Now, we've done problems like this so far this year. Now, these are proportions, all right? We just haven't called them proportions because really what we have here, all right, if I look at this, this is x over 3, and this is really negative 5 over 1. All right, so a whole number really is a fraction, right? But every whole number is divided by 1 or over 1. Now, another way we could look at this, right? And this is kind of how we're going to approach our proportions today, all right, is that we're going to look at this as division, all right? And what we do to undo division is the opposite operation, which is multiply. So, for example, if I would multiply by 3 over here, all right, I'm going to undo the dividing by 3 here. And I would multiply by 3 over 1, and I would multiply by 3 over 1. And notice, what's negative 5 times 3? That's the negative 15 we have here. Now notice what happens over here. I get 3 times x, which is 3x, and I get 1 times 3 in the denominator, which is 3. So remember, when we multiply fractions, we multiply numerator times numerator, denominator times denominator. Numerator times numerator, denominator times denominator. And then look what happens right here. This is really 3 divided by 3. Well, what's 3 divided by 3, right? That's really just 1. So there's my 1x is equal to negative 15. So when I multiplied by 3 here, what happens is it really undid the division here. All right, if we go back and look at this proportion, right, we have 4 over 1 equals x over 5. So I'm dividing by 5. So notice I could multiply by 5 over 1, and I can multiply by 5 over 1. And notice 5 times 4 is 20, and then I really get 1 times 1, which is 1, but we don't have to write that. And then notice what I get over here. 5 times x is 5. 5 times 1 is 5. And then once again, notice I get this 5 divided by 5 here. Well, 5 divided by 5 is just 1. And there's my answer. And so what we're doing here, right, and so notice we don't necessarily have to show this step because when I can go from this step to this step without showing what's in the middle, because 5 divided by 5 is going to be 1. So if I always multiply by what I'm dividing by, I'm always going to get this result here, 5 divided by 5, which is 1. All right, now, if I go back to this guy, and this one is a little bit more complicated, but not terribly so. I'm going to put that negative 3 over 1. Notice I'm dividing by x. So I would multiply by x, x over 1. I would multiply by x over 1. And then once again, this x divided by x, that undoes each other. All right, so the multiply by x divided by x, and that leaves me the 15. I'm just kind of skipping this step right here in the middle. And notice if I multiply over here, I get negative 3 times x. And so basically when the denominator is in the, when the variable's in the denominator, it really becomes the multiplication question when we undo that division. And notice, negative 3 times what is 15? Negative 5. All right, so it's very important that when we look at proportions, what we're going to really do is undo division with multiplication. Now, what makes a proportion a proportion? So let's look at our whole class practice here. All right, so when I look here, so a proportion is really when I have one ratio or one fraction equal to another ratio. All right, now what I want to do is undo the division. All right, and I'm going to start on whichever side the variable is on here. All right, so notice I am dividing the variable by 2 here. So how do I undo multiplying by 2? Or excuse me, dividing by 2 is I multiply by 2, and that's like 2 over 1. And I'm going to multiply by 2 over 1. Okay, now once again, when I multiply by 2, that undoes the division by 2, and that's going to leave me just my x. And then when I come over here, I'm going to just do my multiplication. So I get 7 times 2, which is 14, 6 times 1, which is 6. And there's my answer. Now, you could make this a better answer. So remember, anytime we have a fraction, we want to try to write it in lowest terms. So what number goes into 14 and 6? Okay, hopefully you came up with 2. They're both even, right? So I can divide 14 by 2, and I can divide 6 by 2, and I get 7 over 3. And there's my answer. All right? Okay, now let's come over here to 2b. Now notice, all right, I've got this x in the denominator here. All right, so that's what I want to do. So I want to get the x into the numerator to solve. All right, so now, all right, what I'm going to do is undo this dividing by x by multiplying by x. I'm going to multiply by x here. I'm going to multiply by x here. And remember, that's x over 1. Now, the multiplying by x undoes the dividing by x. That's going to leave me just the 6 here. Then 18 times x is 18x. 15 times 1 is 15. All right, so now I've got the x in the numerator. Now, I want to undo the division over here. So now notice on the right side, I'm dividing by 15. So now I want to multiply by 15 and multiply by 15. All right, then multiplying by 15 undoes the dividing by 15, and that leaves me the 18x. And then 15 times 6 is 90. All right, and now I can divide both sides by 18 to get to my answer. All right, let me grab my calculator. All right, so now, all right, so I can just do 90 divided by 18, and I get 5. All right, and if you didn't know the fact, remember, we can always undo this. Some of you might have known 18 times 5 is 90. I did not. Now, let me show you another way to approach this problem. All right, and so when we look at this problem, all right, there's another way of working it. All right, let me just get another piece of paper here, and I'm just going to rework it right here. Okay, now when we have 6 over x equals 18 over 15. Now, like I said, we really typically want our variable in the numerator. Now, there's a property of proportions that says you can flip the proportion, all right, and it's going to be equivalent. So I can flip the left side here, and I could write this as x over 6 equals. Now, if I flip the left side, I've got to flip the right side. So this is going to go from 18 over 15 to 15 over 18 like that. All right, and so notice that's called the reciprocal properties for proportion, is that I can just flip it. All right, and just so for an example, I can say, like, if we had 4 divided by 2, right, equals 10 divided by 5, right? So 4 divided by 2 is 2, 10 divided by 5 is 2, so 2 equals 2. That makes sense, right? So if I flip it, I get 2 over 4 equals 5 over 10. Well, 2 over 4 is 1/2. 5 over 10 is 1/2. So I still get 1/2 equals 1/2. All right, so it might change what is equal, but not that it is equal. All right, so 2 equals 2, 1/2 equals 1/2. It's still a true statement. And so notice if I do that with this problem, it makes it just a little bit easier, because now with the x in the variable, I can just undo the division on the left side. So I can do multiply by 6 here, and I can do multiply by 6 here. All right, so 6 divided by 6, right? That's the 1, so I get x. Now, when I notice what happens when I multiply this side, I do 15 times 6, which is the 90, 18 times 1, which is the 18. So notice I get to the 90 divided by 18, which is what we had right here. Okay, and then there's the x equals 5. So it's a little bit cleaner, a little bit easier sometimes, that if I have just this one variable, I can just flip, all right, that fraction, all right, on both sides, okay, to make it a little bit simpler to solve. All right, so now let's look at 3a here. All right, so now here's my variable. All right, it's in the numerator, great. So what I want to do is undo the division on the right side. So I'm dividing by 28, so I'm going to multiply by 28, and I'm going to multiply by 28. Okay, and I'm going to put that over 1. Okay, the multiplying by 28 undoes the dividing by 28. That leaves me my x. And then on the right side, all right, I can just do 28 times 16. That's 448. And then 1 times 7 is 7. All right, and then I can just do, all right, 448 divided by 7 to get my final answer, which is 64. All right, so that's pretty quick, pretty simple. All right, so now let's look at 3b. All right, notice here, my variable's in the denominator. Well, so I think the easiest thing to do is let's make it look like one of these two problems, right? So let's just flip, all right, the proportion. So I'm going to make this as 8 over negative 20 equals x over 40, all right? And now I just have to undo the division on the right side. So I'm dividing by 40, so I'm going to multiply by 40. multiplied by 40. Okay, that undoes that. All right, equals to 1. And then once again, now I can just do my multiplication over here. 40 times 8 is 320. 1 times negative 20 is negative 20. All right, and then now I can just do that division fact to get my answer here. 320 divided by negative 20 is negative 16. All right, so hopefully you guys are feeling a little bit comfortable with this. All right, so let's take a look at two more problems together. All right, because sometimes, all right, when we look at what we're doing here, all right, we get more than, all right, x. So we now notice we have an x plus 8 here. All right, okay, so now I'm going to start by undoing the multiplication here. Or excuse me, undoing the division by doing my multiplication. So just like we did before, so I'm going to multiply by 21 right here. Okay, that undoes the division. I'm going to multiply by 21 here. Okay, that undoes the division. Okay, all right, now 21 times 3, that is 63 divided by 7. That's a 7, sorry, equals, and then that leaves me x plus 8. And notice I can still just do this fact like we did before, right? So I can do 63 divided by 7 if you don't know that fact, right? So 63 divided by 7 is 9. So I get 9 equals x plus 8. And then notice now we're back to our original problems that we've been working on, right? I can get this equal to 0 if I don't know the fact. Some of you might be like, oh, 1 plus 8 is 9, so you know x is 1. But remember, if you don't know the fact, we can always just get it equal to 0. All right, and then there's where x is equal to 1. All right, so now let's look at what we have over here. Okay, now once again, the x is in the denominator. So I can still flip this, right? So I can write this as 9 over 2 equals x minus 3 over 10 to get that variable in the numerator. Okay, now I'm going to multiply by 10 to undo that division. That's going to leave me the x minus 3. So I'm going to multiply by 10 over here. Whoops, that's a 10. All right, right there. So 10 times 9 is 90. 1 times 2 is 2. All right, and then I can just simplify this math fact right here. 90 divided by 2 is 45. Okay, now what minus 3 is 45? Some of you might be able to say, oh, that's 48. Great. If not, get it equal to 0. Okay, so 0 equals x minus 48. All right, and that means x is, in fact, 48. All right, so there is, all right, your work for today. All right, and so we'll look a little bit more about this because we didn't quite get to any that have variables on both sides. We'll do a little bit about that, all right, in class. All right, but if you have any questions, comments, any of this that doesn't make sense, all right, make sure you bring those questions to class and we will discuss it then. See ya.